Welcome, this is the 3.4 Ready, Set, Go Homework Solutions. Here we have the ready part, and the question says just to compare and contrast the linear and exponential functions and provide certain information about them. There's a lot of things that you can say about the linear and the exponential functions. I organize it in a very neat way for you. You could pause the video if you would like to see it in full detail. These are the equations. You have the y equals mx plus b, which is slope-intercept form. Then you also have this version, which is the point slope form. Things like you have a starting value, m is the rate or the slope. There's the growth and the decay. Exponential, there's something that looks like this. We have two versions. We have the zero term equation and the first term equation. It varies. There's also starting value here. Here there's a base multiplier. Here there's a growth and decay as well. Right? When to choose linear over exponential. Here you could just read it for yourself. And here are the equations for it. Remember, when we choose linear, it is because we have a common rate and a starting amount or a starting value. But things that grow exponentially, like their slopes aren't constant, there is an exponential function that grows with that. So there's a starting amount, your base, and your exponential up there, okay? So there's a lot of information here. This is just a quick review on when to pick the linear function over the exponential function. Pause it again if you would like to see more detail. Alright, so the main part of this is the function part, is the set part. For each graph, identify the domain and range and whether the function is increasing or decreasing. Use interval notation when stating the domain and range. Alright, here I have the first one. So I'm going to grab this image so we can work using Paint to see this a little bit further. But we already have the solutions there for you to see. Alright, so I say here that the domain was -5, closed at -5, and it goes all the way to 2. What do I mean by that? I mean this. This is -1, this is -2, this is -3, this is -4, but this is -5. This value here, right, takes place at -5, right? It's closed here. Okay, the reason why it's closed is because of that black dot. Okay, then it goes all the way to the right. This is 1, this is 2. Okay, notice here it's opened, right? It's open all the way here, right? It's opened because it's that open dot. So we would say that is open at negative, right? That is open, and that is at 2. That is why the domain here is closed bracket -5 comma 2 open bracket. Okay, the next one we could see at the range, but the range is referred to the y value. Okay, let's see that. Okay. So we look at the lowest value, right? Oop, look, I think, does it include 6? It's open at 6, right? It's open. Right. So my answer looks wrong. It should be open at -6. Okay. Alright, it is open at -6, and then it looks like it is closed here at 5. Okay. Oh, sorry, and it is closed here at 5. So it is open, so open bracket, -6 comma 5, close it. And it looks like it is going from left to right. It looks like it is going down. Alright, that's how we do that one. Good. The next one. Right. So again, same process, okay? we have to grab it like before, and we determine the slope, the domain, and the range, okay? Alright, let's take a look. So I have it right here. Let's look at the domain, which is going to be the x. Okay. Alright, so let's see. Ooh, I see an arrow here. So -1, -2, -3, -4, but it looks like it goes on forever because you see the arrow. It goes all the way to -infinity. You cannot contain the infinity, so it's going to be open there. Right? Then let's see this here. It goes all the way 1, 2, 3, 4. That's 4, right? And that looks like it is opened at 4. Right? It looks like it is open at 4. So this one should be open at -infinity, comma 4 open. Good. Right? Now let's look at the range. Right? The n, it looks like it is open here. Right? It is open here. Sorry. You know what? It looks like it's opened. Right? Looks like it is opened here. Then it is. Looks like it touches that -1. It almost touches it. So we would also say it is open. So it is both open at -6 and -1. So this should be open at -6 and -1. Okay? And because we look at it from left to right, so it looks like it is going down. So we say it is decreasing. Okay? Let's just double check this, right? To make sure that our answers are correct like before. Okay? Normally we want to make sure it is correct because we made errors from before. Okay, so let's grab that image and work in Paint again to double check our answers. Okay, alright, let's take a look. So here, let's look at the domain. Oh. Alright, it looks like it's right. Do you see the arrow? Right, so this is going to be open here, and it looks like it goes on forever. Same thing here, looks like it went on forever as well. So that is going to be also opened. Right, so yes, the domain would be -infinity all the way to +infinity. Okay, because of the arrow. The arrow indicates that it goes on forever and ever. Okay, let's look at this one. It seems like there is no bottom value because it looks like it kept going down. So it is open here, right? And here it looks like it hits a asymptote or a ceiling right here, and that is open at 4. Okay, so that is correct. From left to right, it looks like it's going up, so we will say that is increasing. Okay. Alright, again, this one, I'm just going to show it, just going to give you the solution. For this one, it is both closed at the ends, so the domain here is from 1 to 6. The range from lowest values, -2, all the way to -1. We say this is increasing. Alright, 6. Do you see the far ends? That means it goes on forever. So the domain here is -infinity all the way to +infinity, and we make sure it's opened. The range behaves the same way, -infinity all the way to +infinity, right? And it's up, so we would say it is an increasing function. 7, right? it stops here at -5, so it's closed here at -5. It goes all the way, so that would be positive infinity, and we do not ever contain that infinity, so it is open bracket. The range, it starts at 0, right? It really doesn't touch 0, so I made it open at 0. It goes all the way to positive infinity, right there, and we say that is increasing. 8. 8 looks a little bit weird, but again, the domain on the far left side looks like it went down, so it is negative infinity, stopped here, closed at the 5 value, so the domain is negative infinity all the way to 5, and make sure we close it at 5. The range here, it starts from all the way down on negative infinity in the y, and goes stop here at the 1 right here, so we would say that it goes from negative infinity all the way to -1. Close it at -1. From left to right, it is increasing. Next one, 9. Here we see the arrow right here, so it starts from negative infinity, goes all the way here, the domain. Ooh, no, it kept going, so this should be positive infinity. Yeah, look, it goes all the way to the right. The range, however, the lowest value it ever touches here is 0. It's open at 0. It goes all the way up, which is positive infinity. And we can never contain infinity. We have to always keep that open. And from left to right, it looks like it is decreasing. Okay? Alright, let's look at the go now. The go just asks us to write, we are given a chart, and we have to find the common difference and put it in its explicit and recursive. Here I have the linear equation, and as well as in explicit, recursive, the exponential, explicit, and exponential recursive, right? So here I found the common difference was 2. The explicit, because this is linear, there's a common difference. Y equals mx plus b. I use y2 was common difference. 1 was your 0 value. Here's the recursive. It is just the common difference 2 plus your previous term. 11, same process. I fill in that chart. Make sure I got that 0 value. I saw that the common ratio here is 2. I have the 0, so I end up using the 0 term equation. F of 0 times r to the exponent or to the power of x. Substitute in. Okay. Recursive formula. I use the common ratio times the previous term. It repeats for the same process for number 10 as well. It's a common difference of -4. Here, I couldn't find my 0, right? So I used the point sloped equation here, and it worked out the same way. Okay, watch the other video if you need review on how to use the point sloped equation. Okay, I have a point x1, y1, and I have a slope. That's why it's called point slope, and I get it into y equals mx plus b. Okay, here's the recursive. 13, common ratio is 3. 1 times 3, then times 3 again is 9. Here I'm using the first term because I have the 1 here, so it is f of 1 times r to the power of x minus 1. This is the first term equation for the exponential. Okay, here's the recursive. Here's 14. I saw that the common ratio is 1/2. Again, I'm using the first term for first term equation for the exponential. Here you go. That's 14. 15, there is a common difference. I'm going to use the slope formula to find the common difference, right? Because I couldn't, right? Because do you see here the difference? It goes 1, 2, 3, 4, 5, right? Here it didn't go up that much, right? So I used the slope formula to get that 2. I use the y equals point slope here. Y minus y1 equals m parentheses x minus x1. How did I get y1? Y1 comes from here. X1 comes from here. Plug it in, do some algebra, distribute that 2 to both terms, right? Add 7 to both sides, you get y equals mx plus b. That's how it looks like. Okay, here's the recursive if you would like to see it. 16 common difference here was -4. Again, I'm using the slope formula to find that. I'm using y minus y1 equals m parentheses x minus x1 point slope form to get my equation. There you go. And is that it? Nope, we have 17 as well here. I got the common ratio using the first term of the equation to solve for it. Okay, there's the recursive as well. 18, you're just going to skip that, okay? Alright, there you go. That was all your solutions for 3.4.